And then we have the downregulation in GABA, which is going to generally drive up arousal and then mood and functionality. And although we could break these into other players, I kind of like focusing on the biggest three, which is mood and function and arousal. So arousal, stimulation, whereas this is more the actual neurochemical function in and of itself. So there's a lot of things going on with modafinil. And to understand a little bit more about it, we have to look at the structure, right? So I am pretty bad at drawing little carbons and all that kind of stuff. I can't make a diamond. So we're going to basically look at the structure. Again, forgive me, not accurate. But we can understand the basics, right? So the core of modafinil is this actual sulfur group, right? And then we have our amide group over there. And we have a diphenylmethyl group over here. So the core structure is right here in the middle, right? Why this is important to understand this structure is because the way modafinil gets metabolized is it'll either be hydrolyzed or it'll be oxidized. So if we will actually go ahead and go through the process of hydrolysis, so I'll put this down here. Versus the process of hydrolysis is going to give us the downstream metabolites. So we're either going to have modafinilic acid, or if you're reading the research, it usually says modafinil acid, and other ones will say modafinilic acid, whichever one doesn't really matter. It's the actual acid. So we'll say modafinilic acid, or we have the oxidation, and that gives us the actual modafinil sulfone, right? Now, whenever modafinil gets metabolized, the hydrolysis to give us modafinilic acid is actually happening right here. So it's going to be replaced. And if you're actually having the oxidation occur, that's going to be happening right here. And what we're going to see is actual additional oxygen double bonded there.